Hello and welcome to the Embedded Project Hub. So in this brand new series about IoT using NodeMCU, we will learn about all the IoT things. So in this first tutorial, we will learn about how to push the data from NodeMCU to the server. Okay, so before heading far to the programming, let me give you an introduction. What are all the necessary components we require before you start with the IoT? So first thing we require is a NodeMCU. So NodeMCU is popular name, which is the ESP8266 controller. It is having on-built Wi-Fi, 1 MB flash, 128 KB RAM, and it is 32-bit MCU. 32-bit means it can process 32-bit at a time. So ALU size is 32-bit, and it is low power. So that's why it is very selectable. When you go for IoT or any embedded application, the main feature now for every battery operated embedded application is a power consumption. So it is low power device, and it is having Lua based firmware. So but for this tutorial we will not use the Lua base. We will start programming on C using Arduino. So let me give you some quick introduction about Ubidots. The Ubidot is a cloud platform for IoT. So it will give a built-in API for every device. So now we are using ESP8266, or you can say NodeMCU. So it is having a MQTT API specific for our controller. So it will give data transformation. So what do you mean by data transformation, you will ask? So okay, data transformation means if we are sending some data to the cloud, then it will uh, it should sometime we cannot use the raw data directly. We need some computation, mathematical computation. So it will provide that API to compute the data and perform some action accordingly, whatever is needed. And then it will provide data management. So data management in the sense, it will provide the timing and other things, like when this data came. So it will hierarchically it will store the data, so we can see the data uh, very user friendly. And then at the end it will provide data visualization. This is the main part, like whatever data we have received and processed according, then that data we have to showcase to some end user application. So in application we can show some graph. So and it is providing the many feature for data visualization. It is good. So last but not least, so we will use Arduino for our programming, because Arduino is very common and it is open source ID, and it is having very user friendly uh, tool and everything. Like you can no need to no need any much experience in programming to start programming using Arduino. So it is very user friendly IDE, and it will support library for almost all the development board. So for our ESP8266, it is having all the libraries, so no need to start programming from scratch. If you want to Wi-Fi application, then directly you can use Wi-Fi library. And for our case, we need to interact with Ubidots. So already there is a library available for Ubidots, so we can include that library and start our programming. So time to market is very less, and also we can uh, test our product in very least time. Okay, so this is all about the setup. Okay, so as I told you, uh, we need Ubidots account. So I have already created one account, and you can see it is having all the profile administration doc. So all the created device will be available here, but as of now we have not created any device, so it will not show here. Okay. Okay, so this is our program. It's look like that. I have already written this program, but not to worry, I will explain all the things step by step. Okay, so start programming with the Ubidot, we need to include Ubidot ESP library. So why MQTT? Because we are using MQTT protocol to communicate with the server. So this is the library, you can note it down. So you need to install it manually. Then this is the token. So token is nothing but some you can say unique pin for each and every account which we have created in Ubidot. So for token you can go to API credential. So here you will say default token. So if you click here, then it will copy. But if you want to see the token, then you can go and click here, so you can show the token name. Okay, so for now I have already copied this token, so no need to copy it again and paste it. So the and to communicate with the cloud, you need internet. To connect your ESP8266 with internet, you have to give it the internet, the hotspot name and the password. So for now my hotspot name is ubidots and password is 123456789. So first we need to create a object from ubidots. I have created client and given this token, so it will configure the client with this token. Okay, okay. And then the setup. So in the Arduino program having two major parts: setup and loop. So this setup function will be executed only once when the program will start, and the loop will execute all the time. So whatever the initialization, variable initialization, setup we required only once, all the code we need to put in the setup function, and whatever the code we need to execute repeatedly over the time, those all the code we need to add in loop. So here we have to set the serial board date. So if this is required only first time, then set debug as a true, then connect to Wi-Fi. This is also need only once, because if we have first we are connecting with Wi-Fi, then every time no need to connect it again. So okay, I have added Wi-Fi to connect with Wi-Fi. So here we have created our client object. So you can use the method client.wifi connection, Wi-Fi name and password. Here is the Wi-Fi name and password I have given. Okay. So to begin with the Wi-Fi connection, then start begin and add callback function. So this callback function will get called every time when new event occur. Okay. So in the main loop, we are checking the connection. So client.connect, it will try to connect with our client. Client means this Ubidot platform. So once it get connected, it will come here. So here to push the data to the server, we have one API called Ubidot publish. So we will use publish whenever you want to send some data from your device to server. Okay, and it's required device name. So let's consider if you have a temperature as a, you can call as a one device, humidity sensor you can call as a one device. For now we will name as a device one, and we will add the variable. So like if you have two temperature sensor or some device which have two different parameter, so then you can create a variable. So the variable will be stored in under this device. Okay, so for now we will name the variable as stuff and provide the value as a parameter. Okay, so and then send publish, so it will store in this device. So for another device having two parameter, two variable, and it is giving, we are giving value from parameter 2 and parameter 3. Okay, then publish that value to the device 2. Then we will use client.loop method to give it certain time, because this loop will execute continuously. So we have to give time to client to read the data and for synchronization. So every time when we are sending data again, at the end we have to use this client.loop, so it will give enough time to client to process the data. So okay, the next, to not to send always continuous same data. I have added parameters with incrementing value. So this parameter incrementing every time with zero point 0.5 value, with this one is with zero point 0.2 and this is the one. And I have given delay of 1 second. So every 1 second we will send some data on cloud. So this is all. Here I have declared all the variable globally to access it in another function. So let's try to compile this. Hope it will compile without error. And until it compiles. So as you can see, okay, it's compiled successfully. Yeah, it compiled successfully. Let's press it. Okay. So as you can see here, for now there is no any device we have created. So if there is no device, and we have, but from program we are trying to push the data in the device 1 and device 2. So it will not give any error, but unless it will create the device 1 and device 2 on server side. So no need to worry, it will create the device and it will create the variable inside whatever we are sending to the server. Okay, the program is flashed. I can press hard reset and check the serial monitor. Okay, it is sending some value. Let's check on the refresh it. Yeah, you can see, right, two devices connected. Device 1, so in device 1 one variable should be created. Yeah, we can see here one variable with the value having 19 point. So you can see it is having value 10 point, 11 point, 20, 70, 12, 30, right? You can see the value is incrementing over the time. Yeah, good. So let's check another device. Device 2 is having two variables, stuff and more stuff. So here you can see the value is incrementing every second. Yeah, okay. So here you can see 11, 13. This is incrementing by 1 because we have added one incremented at every second. It's good. Also here it will see when the data arrive with the time. So all the data you can see, how many data you can see, like 10, 20, 50, 100 in this page. So here are some few characteristics. You can add some unit tag. Okay, you can use this ID. Let's see another. Hmm, this variable is incrementing by 2, right? Yeah, it's incrementing by 2. Point 2 means yes. Okay, same here. Okay, all good. So you can see your device from here. You can change the layout. You can make it like this. Yeah, it's good. So in this device it will show how many variable is there, two variable, one variable. Okay, so and from here serial window we can see when the data is, what data device is sending. Okay, that's it for today. So in next tutorial we will see about how we can read the data from cloud and change some hardware. Let's consider like how to blink the LED when some data has been changed on cloud. So that kind of program we will see on next. Okay, so hope you enjoyed this tutorial and see you next time. Bye bye.